Okay, so let's scientific first one. We'll go through the first one. How do you guys feel about that very first question? How you feeling? You guys on on Zoom? Can you guys see my screen?
Yes.
Yeah, you see the
Yes, we
questions?
can. Yep.
Okay, good, good. Okay, so the questions on the screen, and you'll all be able to see. I have to do something like this. I can keep that break. Okay, so and let's start with the very first one, right? We know that when we're working in chemistry, we have to be able to manipulate our numbers and stuff like that. Yeah, you guys remember that pretty well, right? Okay, so the very first one, if we want to put that one in scientific notation, what are we going to do? We're going to do what? Move some decimals. I like that. Let's move some decimals there. Okay, so we're going to move those decimals, and this way we're going to be moving it backwards. So that'll be 1, 2, 3, 4, 5, 6. So since we're moving it backwards, is that going to be a positive or negative? Negative. Okay, good. So we know that that's going to be 4.3 times 10 to the minus 6. Did you guys all get B? Okay. Piece of cake. You're like, man, come on. Now challenge us a little bit, right? Okay, number 2. Sig figs. You guys love this topic. It's your best topic. Now, I'm going to tell you this, right? Now, we can go over it, but we only have a one question. Basic, a very basic question, kind of like this one. Okay, so how many sig figs do we have in that very first one? A. We have 2. Are you sure? You want to put money on that one? No, but we took the time to write those zeros, right? So because you got to think about it. The way I always think about it is I'm lazy, right? Especially if I'm up those stairs. I'm damn lazy, right? So do I really need those zeros after that 4.3, right? I mean, sorry, that 0.043. Do I need those zeros? No, right? So if somebody took the time to actually write something more than what they need to write, that's typically a sign for us, right? That usually means that they're going to be important. Okay. So in this case, we know that the 4, the 3, and those zeros following it are going to be important because somebody took the time to write it, right? Because if it's not necessary, are you going to do it, right? You normally use just like 0.04, that'd be good enough, right? Unless you're trying to tell me something like important, right? Okay, what about the next one, B? So we know that that first one had 4 sig figs. What about this one? How many would that be? That would be 3 sig figs, right? Because we know that that cap to zero, the zero in the middle, right? Okay. Now, what about here? How many sig figs we got here? Let's see. We have 3, right? So that one is the correct answer because that one has the correct number of significant figures, right? It has 3. So that, in that case, those zeros are showing, right? Those aren't important, but they're and let us know the value, right? And so that's the biggest thing, right? Sig figs are kind of getting it, right? Yeah, and you got that's the way you say it. How many sig figs are getting out of that? But it's just we need to realize we have zeros that are as place. Let us know the value, right? And then we're gonna have zeros that are, they're not gonna be important. They're just kind of letting us know, hey, they're just here for value purposes. And that's that case. Okay. So the correct answer should be C. Did you guys all get that? Can you guys see it? You know, like I said, you're gonna have only one question that's gonna be like that. Okay. So now, when we're doing multiplication and division with sig figs, what is the rule? No, that's addition and subtraction. So addition and subtraction, we have to line up. Tell me if you guys can't hear me because, just getting my hearing back and everything. I feel old. I'm telling you now, I'm feeling really old today. Had to wear my glasses because I'm supposed to put my glasses, so I can see stuff. Um, so, rule about multiplication and division. Remember? So we know it's not lining up. What is the other rule? What was that? Um, least sig figs. Okay, so we know that we need the least sig figs. So in the first case, what is the least sig figs in the situation? Now, there's a couple of things that we do want to keep in mind. One of the things is that if it's a conversion, we don't use that to determine our significant figures, right? But we want the least number of sig figs, right? So that first one is a conversion. 1 meter is equal to 39.4 inches. That would be conversion, right? So we don't have to worry about that. But we take a look at what we're starting off with. So how many sig figs do we have there? We have 4. So our answer should end up with 4 sig figs. What about number 2? We have 2 we're starting off with. So then how many sig figs should we have? We should have 1, right? And we end up with 3. So we know that that is incorrect. Okay. What about number, we'll see. We're starting off with how many sig figs? 4. But we know that that second part is conversion. So does that look about right? How many do we end up with on the other side? 4, right? So we know that that would be our correct answer. So the correct answer should be C for cat. Meow. Okay, now we're going to see how your skills are with equivalencies and conversions and stuff, right? Ooh, ooh. Sorry, I get anxious. I have to say, I missed you guys. It's good to be in front of a classroom. Did I get a hit on myself? I did. Okay, so which of the following measurements are not equivalent? We have 25 micrograms is equal to 0.025 grams. You have one question that's going to be like this as well. I'm sorry, milligrams, not micrograms. You're right. Milligrams. Milli. My bad. So we have 25 milligrams, and that is equal to 0.025 grams. So that's true. Okay. So that one's okay. Okay. What about B? What do you guys think about B? We have 183 liters is equal to 183 kiloliter. Is that true? Yeah, no? Sounds right. Okay. So that one looks good too. Okay. What about C? We have 150 uh, millisecond is equal to 0.150 seconds. Milli to second. How do you guys feel about that one?
That one is incorrect.
You said that one is incorrect. Well, isn't that kind of similar to what we see in number 25? If we go over 3 spots, there's 1, 2, 3. So like not 25, in A, sorry, in A, isn't that kind of similar to what we see in A? So we just go over by 3 1, 2, 3, that would be the same, right? So no, that one's actually correct. Okay, so what about the next one? D as in donkey. What do you guys think about that? So we have 84 centimeters is equal to 8.4 millimeters. Centimilli. So 1 centimeter. Let's see if I can remember this right. So 1 centimeter would be equal to how many millimeters? What was that? Yeah, you said 100. Are you sure it's 100? It should be 840 millimeters. That's right. That's right. So if we had 840 centimeters, that should be 840 millimeters, right? Because we know that it's 10 times greater, right? So it should be 10 times greater, right? Because there's centi is 100 and milli is 1,000, right? And so that means it's just 10 times more. So then if we had 84 centimeters, that should be 840 millimeters. So D would be our incorrect answer. So D was the one that we're looking for. D as in donkey. Do you guys see that? And so on the exam, in the back of the exam, there's the periodic table, and then there's conversions. Now, not true conversions. What they'll do, they'll say centi, right? And they'll say centi means 10 to the minus or 10 to the minus 10, right? And then they'll say milli means 10 to the minus 1,000, right? Or 10 to the minus 3, right? And so use that information to kind of help you work through it, so kind of take that as a hint, you know. So no, no, unfortunately. But there's not a lot of conversions, right? The ones like they give you the conversion numbers that you need, they do it for you in the problems. A lot of the questions are, I like to tell people, big picture. Right? If you think about big picture questions, that's what they are. Kind of like they're not hard questions. They're just kind of big picture. They want to make sure that you understand the big concepts. Okay. So we're going to skip over some of this conversion here, but we're going to go over here to density because we want to remember what density is. Okay, so number 7. How do you guys feel about doing number 7? Yeah, cool with that? Number 7? You need help with that one? Okay, so let's see what we can do with that one, right? So first off, what is the definition of density? Mass, not mass times volume, but mass over volume, right? So mass divided by volume, okay? So we know that density is always going to be mass divided by volume. Okay, so a nugget of gold with a mass of 521 grams is added to 50 mils of water, right? 50 milliliters of water. The water level rises. Now, this is the important part. The water level rises to a volume of 77.0 milliliters. What is the density of gold? What is the hint there? What are you trying to get at by the water rising?
The weight?
It's the difference of volume. It's not the weight because they gave us the weight, right? They already gave us because we know that grams is weight or mass, right? So they gave us the weight, but they told us, they said, now you added 50.0 milliliters of water. And when that happened, that went up to 77.0. So that means that the volume that's being occupied by that goal was how much? What was that? It was 27. So the volume change was 27, right? Okay, so we know that the volume started at 50 and then went up to 27. Okay. So then that lets us know that we're going to be dividing it by how much. You guys were able to find it. You got my crazy message. Sorry about that, guys. I guess maybe I should open it. Okay, so then what are we going to do? Because we know the volume and we know the mass. That's right. So what you got 19.3 G? Good job. So you guys got E as in Edward, right? Because we know that the change, and this is one of those big picture, it's like, oh, we got to think about what happened, right? So we know that it went from 50. So we went from 50 all the way to 77 milliliters. And we know that milliliters is going to represent volume, right? Anytime you have liters, you have gallons, anything like that, we know that that's going to always be volume. So then we're just going to take that difference, right? So we know that's 27 milliliters. So it changed 27 milliliters. And then we just take our mass, which is 521 grams. I guess I should put my zero there so that I keep my sig figs right. And then that's how we ended up with our 19.3. Okay. ¿Preguntas? Okay. So, which of the following substances will float in gasoline, which has a density of 0.66 grams per milliliter? A, table salt. B, balsa wood. C, sugar. D, aluminum. And E, mercury. Think about it. What float? They all float, right? They all float down here or something like that, right? Is that right? Yeah. So why would you float, right? What do you guys think? Well, is that you're lighter, right? Our density is going to be lighter. That's right. So which one has the lighter density? B. B as in boy. That's right. Balsa wood. Balsa wood has lighter density. So that's like the big picture question. So here's the key. Half your questions are going to be calculations, and half of them are going to be big picture, right? Okay. So we're going to see if you guys can recognize units. Got carried away. It's so happy. Number 9, it says milliliters. Would that be mass, volume, distance, temperature, or density? That would be volume. That is correct. Good job. Volume is B as in bon or boy. I'm gonna give you a nickname that my cousin has, but that's all right. Um, millimeters or mm. What would that be? That would be distance. So that's C. Okay. Grams. That'd be mass. 127 degrees Kelvin. 127 Kelvin temperature. That's right. That's donkey. D is in donkey. And kilometers. That'd be distance. Milligrams. Mass. Okay. So that would be 8. Okay, let's see. Let's get into some good stuff. And I don't know how I get so fast. I move down so fast. Okay, so let's talk chemical changes. How you feel about that? Since we kind of got those units down pretty good. Okay, so when a solid is converted directly from a gas, when a solid is converted directly to a gas, the change of state is called sublimation. That is correct. Good job. Okay, number 24. In a gas, the distance between the particle is A, very close relative to the size of the molecules, close relative to the size of the molecules, fixed relative to the size of the molecule, small relative to the size of the molecules, very large relative to the size of the molecule. Think about what gases. What do we know about gases? What was that? E as in Edward, that is, right? So we know that they're going to be large relative to the size because the distance between them is 3.5. Because gases are going to be very, so leave me alone, don't touch me, right? I got my own damn space, right? So helium is, or a or an a compound. Is it a compound? No. It is an element. That is correct. C is the correct answer. Air. Air is a compound, a heterogeneous mixture, an element, a homogeneous mixture. That is correct. D as in donkey, homogeneous mixture, right? Because we know that air is made up of oxygen, but all of them are independent of each other, right? And they, which of the following is a chemical change? A, cutting a rope. B, bending a steel rod. C, making a snowman. D, burning sugar. E, melting gold. You said D as in donkey? That is correct. Burning sugar, right? Remember caramels in the very beginning? Yeah. Which of the following is a physical change? A, baking a cake. B, dry ice subliming. C, fermenting grapes to produce wine. D, digestion of a meal. E, tomato ripening. B as in boy. Do you guys agree? Why isn't it E as in Edward? Because when a tomato ripens, right, it gets sweeter, right? So that means it's making more sugar, right? So that's a chemical reaction, clearly, right? Okay, so the correct answer is B as in boy. Good job. Does that make you guys sweat when I ask you? Sure. Because digestion, you know that that's what's breaking stuff down, right? Is that a chemical reaction? Decomposition, right? You digest bodies. Try to get rid of them and stuff. Okay. How many calories are required to raise the temperature of 150 point 150 point grams sample of gold from 25 degrees Celsius to 175 degrees Celsius? The specific heat of gold is 0.0308 cals grams Celsius. What do you guys think the equation is? Yeah, remember it? How many of you guys want to be doctors versus no doctors here? What is that exam that the doctors take? You guys don't know what the exam that the doctor take? Y'all didn't watch enough of Grey's Anatomy or something like that. It's called the MCAT, right? So that's my hint, right? So we know that it's the equation is Q. Q represents the heat is going to be equal to mass, specific heat, times delta T. Okay, and we know that delta T represents the change in temperature. And guess what? You know, our units are beautiful here. They work for us nicely. They're all in Kelvin. I mean, not in Kelvin, in Celsius. So we can just do straight subtraction. So we go from our final temperature, which is 175 minus 25. And that's going to equal was that 150? Now, y'all don't have to make me feel good and tell me yes and I'm wrong because I've been sick. Okay. And we know our mass. We are given our mass, right? Where's our mass? So 150 grams. I was like, man, we did this at the very beginning of the class. You expect us to remember all of this? And then our C is our specific heat. And so we know that that is going to be our 0.0308. And that's going to be calories grams, calorie per grams, degrees Celsius. And then we just plug that into our equation. Okay, so then our Q is going to be, plug that in. So we have what, 150 squared, or 150 times 150, because that's our mass and our temperature. And then let's do it. 0.008. And then that's 150. Okay, you have 30 minutes left. – 693 calories. Oh, and it's on there too. How about D for donkey? It always makes you feel better when the answer's on there. But usually they're pretty good because, you know, all the ones that you make mistakes on, they have them on there too, right? Man, I forgot to multiply that by two, you know. Okay, let's go to the next one. Are you guys ready? Let's do it. Feeling good. Okay, so we're going to go through this real quick, right? So you got to tell me if it's a physical reaction or a chemical reaction. You guys at home, are you guys ready to play? I want to hear some nodding. This is a group effort. Okay, 30. It says water evaporating. Is that physical or is that chemical? Let's get physical. That's right, physical. 31. Silver tarnishing. You guys know tarnishing? It's kind of like rusting, right? So it's what silver does, kind of rusting, right? So it gets all that black color to it and all that stuff. What do you guys think that is? Chemical. That's right. That is a chemical reaction. Good job. Um, Cutting of grass. That's physical, right? I sweat just looking at it. Nails rusting, not your fingernails. That's chemical. Baking a cake, chemical. Placing a photograph in a scrapbook, physical. The formation of green leaves on a plant, chemical. Burning of leaves, chemical. Melting ice, physical. Piece of cake, right? And again, like I said, you're going to have one question that was definitely like that. And you guys are going to be like, he's not serious. This can't be right. Don't talk yourself out of the right answer. Y'all think I'm kidding. That's usually what happens. You'll know the right answer and you'll be like, oh, that's too easy. That's just too easy. You know? Yeah, it's a trick. He's tricking us. Yeah. Which of the following elements is a metal? A, nitrogen. B, fluorine. C, argon. D, strontium. E, phosphorus. D, that is correct. D as in donkey. That is a metal. Which of the following elements is a noble gas? A, oxygen. B, chlorine. C, bromine. D, argon. E, nitrogen. D as in donkey again. Argon. The element in the list which chemical properties are similar to magnesium is A, sodium. B, boron. C, carbon. D, strontium. E, chlorine. D as in donkey. That is correct. Which of the following is a subatomic particle? Sorry. Which of the following describes a subatomic particle? Okay, let me see if I can read this correctly. Which of the following descriptions of a subatomic particle is correct? A. A proton has a positive charge and a mass of approximately 1 AMU.
A.
B. A is correct. That is correct. A. Go ahead. She didn't let me finish. She's like, A. That is correct. So we know that protons have mass associated with it because we know that that makes up the mass of the atom. And then also, what is the other one that makes up the mass of the atom? Neutrons. That's right. Electrons are so light, right? They don't affect the mass at all. And they're negatively charged. That's correct. Okay. 43. The mass number of an atom can be calculated from A, the number of electrons. B, the number of protons plus neutrons. C, the number of protons. D, the number of electrons plus protons. Or E, the number of neutrons.
B.
B is correct. Good job. Good job. Y'all are on fire. El Fuego. See, maybe I should just give y'all a week off every time, for the exam. Let's see. The correct symbol for the isotope is potassium. I said the correct symbol for the isotope of potassium with 22 neutrons is
A.
A. You guys say A? Okay. Everybody says A. 41, 41K19. Okay. Anybody disagree? Okay. Works for me. Okay. So let's move on. That's good that you guys didn't put P, right? Y'all didn't pick D or, y'all recognize that potassium is K. Because there's a tendency, and I'll say this happens quite a bit. You look at potassium, you're like, oh my God, it's potassium. And you're gonna, so don't do that. Know your symbols. And if I remember correctly, they spell out what the chemical is with the symbol just in case. Okay, so which of the following gives the correct number of protons, neutrons, and electrons in the neutral atom of 118 SN50? A, 118 protons, 50 neutrons, 118 electrons. B, 118 protons, 118 neutrons, 50 electrons. C, 50 protons, 68 neutrons, 50 electrons. D, 68 protons, 68 neutrons, 50 electrons. E, 50 protons, 50 neutrons, and 50 electrons.
C.
The correct answer is C. That is a good job, guys. It's all coming back. You guys are doing good so far. Okay, isotopes are atoms of the same element atoms of the same element that have A, different atomic numbers, B, the same atomic number, but different number of protons, C, the same atomic number, but different number of electrons, D, the same atomic number, but different number of neutrons, E, the same atomic mass, but different number of protons. D is correct. That is correct. Number 47, a sample of chlorine has two naturally occurring isotopes. There'll be a problem on the exam like this. So, the sample of chlorine has two naturally occurring isotopes. Isotope Cl35, mass 35.0 AMU, makes up 70.8% of the sample. Isotope Cl37, mass of 37, makes up 24.3% of the sample. What is the average atomic mass for chlorine? Any suggestions how we would go about this? Now, your first instinct, because I know that you guys are getting in the habit of average, right? So your first thing that you guys are going to do, and this is what everybody always does, because this is average, you guys will add up two masses and divide it by two. That is wrong, right? So if you did that, that's wrong, right? Because we know that there is more, which one is more abundant, 35 or 37? 37, right? So we know that that's more abundant. That means that we have more incidents that we're going to come across that 30. Did you say 37 is more abundant? You mean 35, right? Isn't it? Because there's 75.8% 35 and there's 24.3%, right? So they're not equal abundant. So that's the reason why you can't add them up, and add them up together. We know that one of them is more than the other. So we got to account for that. So the simplest way of doing that is just taking this, making it into a decimal, right? And so instead of having a percentage, we're going to make it 0.75, right? So, or 0.758. So we're going to go 0, 0.758. And then we're going to multiply that times 35. Okay. And then we're going to add that with that 0.24. Three. And then we're going to multiply that by 37. And then we're just going to add it together. And then that's going to give us a value. Now, if we pay attention, that value, right? So the ones that you're closest to, right? The ones that is most abundant. So we said 35 is more abundant than 37. So then our value, since that's more abundant, it should be kind of closer to that 35 than the 37, right? In terms of our value. So if we go ahead and do that math, what did you guys end up with? It's a 35.521. Yeah. Okay. So now here's that sig fig question, right? So now we're talking about sig figs, right? So we have how many sig figs do we have here? I'm cheating here. My zeros is point 0, and this is point 0. What was that? Would it be 2? Right. So technically these are point zeros. I cheated. I fixed it. So then I have 3 sig figs times 3 sig figs, right? So then that should give me 3 sig figs, right? And then I have 3 sig figs times 3 sig figs. That gives me 3 sig figs. When I add them together, that's probably going to add up to 3 sig figs, right? So we should end up with 3 sig figs. So this would be your correct answer. Now, I will say on your exam, you won't get anything that's that exact, right? I mean, they'll give you something. They'll be definitely apart from each other. You won't get the one where you have to worry about the sig figs. Yeah, only you have that one question that they ask you specifically about sig figs. That's it. Okay, does that help? Okay. Now, anytime that you come across this problem, you always want to look at the percentage, and then you're also going to take into consideration the uh, the mass, right? So multiply that percentage by that mass and add it together. And you know that value can't be because it can't be greater than it has to be somewhere in between the two, right? It can't be greater than the higher number, right? And if you get anything greater than the higher number, that should be a first, hey, wait a minute, I did something wrong, right? So it always has to be somewhere in between. Because if you notice, all of their answers were all in between, right? In between 35 and 37, right? So pay attention to that. Some exams, they don't pay that much attention and they just kind of, they're saying if you just know what you're doing. Okay. So here we go. Now, this is one that they want you to think about a little, right? The next one. It says a sample of silicon has 3 naturally occurring isotopes. We have Si-28, which is as a mass of 28.0 AMU, Si-29, which has a mass of 29.0 AMU, and we have Si-30, which has a mass of 30 AMU. The average atomic mass of silicon is 28.1 AMU. Which isotope is the most abundant? Anybody want to take a gamble? A. Why A? That's right. That's right. Good job. El Fuego. That's right. And so you're paying attention to that average. That average lets you know the one that's going to be the most abundant. Right? Good job. I love it. You guys are brilliant. You don't know how It's weird. But you guys coming today, coming prepared, and doing what you guys are doing right now, you have made my fucking week. I've been trying to get my grading done, and my other class, my online class that's completely online, they make me want to cry. I'm like, I'm getting ready to quit teaching and everything. They had me in tears. But you guys make me feel a whole lot better. Okay, the number of electrons in the outer energy level of a neutral atom of boron, number of electrons in the outer energy level of a neutral atom of boron. Atomic number 5 is, what was that? 3. That is correct. That is correct. That's pretty awesome. Yeah. How did you figure that one out? It's the valence. That's right. That is right. So that outer energy level is going to be that valence. Good job. So, which is the electron configuration for potassium? Atomic number 19. Now, if they're listing out all of the numbers, let me give you a hint, right? So if it's atomic number of 19, how many electrons should we have? How many electrons? What is the total number of electrons? 19, right? Because it should match up the number of protons, right? Because they have to balance out. So one quick way of doing it is just counting the total of your superscripts, right? It should add up to 19. So that's one way of getting rid of some of the things that may not make sense. We also know that S can only hold how many electrons? 2. That's right. And then P can only hold how many electrons? 6. Okay, so that's another way of getting rid of them. So if we know that, so we can get rid of them. Man, we got rid of this one because we know that that one has 8. We know that P can't hold 8, right? So we got rid of that one. So we also know that S can only hold 2 at the max. So we're good there. Okay, so those are all good. Good. Okay, we got P, that's 5. Okay, so maybe. Okay, so now here we need to make sure that there's 19. So there's 2, 4, that's 10, that's 19. Okay, so that one's feasible. So that's 10, that's 19. Okay. Here we have 10, that's also 19. Okay, so that one ain't helping us any. So this one has 10, 7, 18. So we know that that one can't be right either. Is that right? Make sure I count it right because I will make a mistake. Yeah, that's 18. So we know that that one can't be right. Okay, so if we know that, so then we know 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, right? So that one looks correct. Oh, we also know that this one is wrong because that one has 7, right? So, so D as in donkey. Okay. And they're really good about giving P 8 and 9 and 10. And so if you remember that P only can hold 6, that's going to help you out. Okay. So the number of dots in the electron dot structure of carbon. 4 is correct. 4 as in, well, D as in donkey. Okay. Ooh, now we get to see some classification of elements. See, hey, test those skills real quick. Okay. So 52, sodium. What type of element is that?
Alkali
Say
metal.
alkali metal. That is correct. Argon. You said noble. That is correct. Bromine. That's right. Halogen. Copper. Transition metal. That's right. Magnesium. Alkaline earth metal. That's right. Phosphorus. It's a non-metal. That's right. And I think, if I remember, I think there's 2 questions like that on the exam. And again, you'll be like, don't overthink it. You guys got it. It doesn't have it nicely, but it shows you where the metalloid is. And so you use that as always use that as a reference because the metalloid is the separation between non-metals and metals, right? So use those metalloids. So it'll show the jagged edge of the metalloid. And remember, silicone is a metalloid. I always remember that one. If you remember that one's a metalloid, it kind of gives you reference where everything's at. And it's only like 1 over and stuff like that. So yeah. Okay. We're going to skip some nuclear chemistry, although we do. Oh, actually, no, we're not. You should know this. Okay, so the nuclear symbol for the radioactive isotope of copper with a mass of 60 is A.
A.
That is correct. So this stuff, these things, if you guys come across these problems, because we did not go over a lot of this, we ran out of time. And so if you get it right, it's extra credit points. If you get it wrong, it's not going to affect you. Okay. So it'll just be added on. So, but I'll help you guys out with this one. Okay. So, in the case of nuclear symbol for helium, right? So if you see this as the nuclear symbol, this also signifies a alpha particle. Okay. So this also signifies an alpha particle. So it would be E as an N. And the reason why it's considered to be an alpha particle is because it's the positive, it represents a positive charge and everything like that. And so it's just the nuclear component. It's not the whole thing, it's just the nuclear. So it's just that positive. Okay, so here, this symbol here is going to be used for that's right, beta. Yep. Okay. Now, here is the secret to this, right? At the end of the day, both sides have to add, right? Okay, so that basically means the mass has to add up and the number of protons have to add, right? So if we have a 5 and a 2 here, that adds up to 7, right? So that basically means over here on this side, that means that this has a 0 on the bottom, right? And then we got to figure out what's that's on top. So then we have a 10 and a 4, right? So 10 plus 4 is what? 14. We have 13 here. So what has to be at the top up here? A 1. Okay, so then basically we're saying that we're increasing the mass. So what increases the mass? A neutron. That's right. So the correct answer would be a neutron. Oops. Sorry, let's see. So we're adding a neutron. Okay. So anytime that you end up with a 1 and a 0, that means that you're adding a neutron. Okay. Now down here, we have 59 on this side and we have 55 plus something. Okay. So, but this one is 74 and 72. So what has to be down here at the bottom? A 2. Okay. And then what has to be up top? A 4. What did we see earlier that had 4 up top and 2 on the bottom? It's the alpha particle. That's right. Or we'll also say He, right? So you would say alpha particle. That is correct. So helium. And I'm going to say, if I remember correctly, I think there's 1 or 2 questions on there. But then look at it. It's a freebie. You get it right? Perfect. You get it wrong? I'm going to hurt you. Okay. Okay. We're going to skip this. And we're not going to talk about the half-life. Okay. Compounds and their bonds. How about that? Man, we're doing pretty good. 67. Okay, how many electrons will aluminum gain or lose when it forms an ion? Aluminum. A, lose 1. B, gain 5. C, lose 2. D, lose 3. E, gain 1. D as in donkey. It will lose 3. That's right. Because remember, it has a plus. Awesome. Wasn't too bad. Yeah. Good job. Thank you. Well, I'll have it for you. Who knows? No, you better tell them. Yeah, let them know. No situation. But are they going to be able to? Are you going to? Are you going to? You can have you zoom in. Yeah, you can zoom in. Okay, sounds good. Okay, good. Okay, so we'll have you zoom in for the presentation. Okay. Yep. Yeah, I get all the papers. Yeah, at the end. Yeah. So yeah. So I find people find the most incredible ways of trying to cheat. So yeah. Yeah, I have to collect everything at the end, unfortunately. I prefer giving it to you because then that way you guys can look at it and pine over it, figure out what you figured out wrong and stuff like that. Okay. What is the symbol for the ion with 19 protons and 18 electrons? 19 protons and 18 electrons. You said potassium. Okay. So which one can we get rid of since we know it's potassium? So we can get rid of A, we can get rid of B, we can get rid of C. Okay. So it's either one of these two. What do you guys think it is? It's plus. That's right. So it would be E. Good job. Um, there is I don't remember. Show you my favorite question. One of my favorite questions that they love doing on the exams. Uh, I'm going to put it up here right now because they don't have an example of it. You know how like they draw images and stuff. Okay, so they'll say, okay, uh, okay. So they'll say, Which one best represents an element? Let's see. So it will be A. This will be B. This will be C. And then this will be D. Okay. So which one of those best represents an element? Nope. Not C. What was that? Not D. Nope. B. B would be the correct answer, right? What type of element? If the circle represents a single atom, what type of element is it? Not carbon, because carbon isn't this type of element. Gotta breathe sometime. Oxygen. Oxygen is what? No. Now represent. Now remember, it's representing a circle is representing a single atom, right? So if you have two circles that are stuck together, that means it's what? What type of element would it be? Start to say it again. Diatomic. That's right. So that's an example of a diatomic element, right? Because it's two circles stuck together, right? Where the first one, you have a circle and a triangle, right? So that would be a compound, right? So that's kind of like carbon dioxide, okay? And then this one is a circle and three triangles, right? So then that's kind of like uh, ammonia, right? And then this one would be an example of a mixture, right? So you have two compounds that are alike and then two other compounds. Okay. So that's what like big picture. There are things like that. And then your first instinct, what do you guys do? You're like, what the fuck is he drawing? Right. And you're like, you didn't think about the diatomic, right? If you think simple, just try to think simple. Right. And there's a lot of questions that are like that. That are like, just think simple. You know? So you'll have a question like this next one too. Um, the correct formula for a compound formed from elements of Al and O is, you said B, E, as E as in Edward. E is correct, right? Because we know that aluminum has a +3 charge, right? And then we know that oxygen has a -2 charge. And then you could just do the cross multiply thing, 2 and 3, right? So then you just end up with Al2 O3. Is this helpful? Is it? Yeah. I guess we'll know on Friday, right? We're like, yeah, we'll know then. Let's see. Okay. Number 70. The compound magnesium chloride. Damn it. Okay. Well, you guys know the correct answer. Yes. So the reason why it's not C because we know that these two metals are always but then that the only ones that we put Roman are transition. Gotta remember that. So transition metals are the ones they get the Roman numerals, like number 71, right? Yep. And I was gonna do the same thing that I just did right now. Like, I'm glad I caught myself. So yeah, I have to try to remember how to say this without saying it. Fe2SO4 parentheses 3 is called
C.
C. That is correct. Okay, so we know that here, right? We know that, well, first off, we know that the sulfate, it has a -2 charge, right? And so that means that the iron has to be that +3 for everything to balance out. Okay, good job. Okay. So, which of the following element does not exist as a diatomic? I believe that there's a question like this on the exam. What was that?
Carbon.
Carbon. That is correct. That is correct. Oh, this is a good one. Choose the best electron dot structure for OCl2.
E.
E as in Edward. Okay. You guys agree? Yes. That is correct. E as in Edward. Because everybody has 8 around them. Right? Yep. Okay. The correct name for the compound NCl3. That is correct. E is correct. So it would be nitrogen trichloride. And that's because we know that covalently bonded compounds, we use the Greek prefixes. Good job. So which of the following substances contain a nonpolar covalent bond? A, water. B, sodium chloride. D, ammonia. E, magnesium fluoride. D, magnesium fluoride. E, nitrogen.
Nitrogen.
Nitrogen. So nitrogen, we know that nitrogen is going to be non-polar. Right? Polar basically means that you have, one is pulling more than the other and stuff like that. But if they're evenly shared, right? So they're like twins sharing. Okay. Number 76. Which of the following compound contains a polar covalent bond? A, sodium fluoride. B, uh, hydrochloric acid. C, or I guess that wouldn't be hydrogen chloride. Uh, C, bromine. D, magnesium oxide. Or E, oxygen.
B.
B as in boy. That is correct. Okay. Which of the following compounds contain an ionic bond? A, ammonia. B, water. C, calcium oxide. D, hydrogen. E, methane.
That was
C, that is correct. We have a metal and a non-metal. That's right. Okay, so the electronegativity difference between X and Y is 2.1. Bond between X Y is A, ionic, B, nonpolar ionic, C, nonpolar covalent, D, polar covalent, E, impossible. A, it would have ionic character. That is correct because it's greater than 1.8. The shape of ammonia, uh, the shape of the ammonia molecule is A, linear, B, square, C, pyramidal, D, hexagonal, E, octagonal. So let's think about those other ones. Those last ones. Hexa means what? Hexa means six, right? Six. So we're thinking about something that has six. We only have three things that are attached to the nitrogen, right? So chances of it making something that's six is going to be like almost impossible, right? So we can kind of eliminate that one. Octa means what? Eight. So we definitely can eliminate that one. So we know that those are definitely out of the way. So we have nitrogen, which we know is probably going to be in the middle, right? And then we have a hydrogen, a hydrogen, and a hydrogen, right? So there's three sides to it. So technically, right? Let's draw that out. So do you guys think it'll be linear? Linear means it's a straight line, right? What was that? You said it's C, right? Okay. So we know that we can really get rid of that one, right? And nothing forms a square. If it forms a square, that's a problem, you know. So, so we know C. Okay. Now here we have carbon dioxide. We know that carbon likes to be in the where? In the middle, right? Carbon's a little bit of a whore, likes to be in the middle. Okay. So that means the oxygens are going to be on both sides, right? So chances are this is probably going to be what? Linear. That's right. Okay. The strongest interaction between molecules of ammonia are A, ionic bonds, B, hydrogen bonds, C, polar uh, polar covalent bonds, D, dipole dipole, um, E, dispersion. We didn't talk about this. We didn't get a chance to talk about this. And so it was in the chapter, but really didn't talk much about it. So I'm going to give you a hint. Okay. Anytime that you see interaction between two molecules, right? So that's we call them IMFs, intermolecular forces. And it says interaction between two molecules, and you have nitrogen and a hydrogen, right? Nitrogen and a hydrogen together, right? So that basically means you're going to form hydrogen bonds. Okay. If you have oxygen and a hydrogen, you're going to form hydrogen like water. That's and then if you have and uh, and hydrogen, then that means you're going to form hydrogen bonds. So when you have hydrogen has to be hydrogen interact with oxygen or nitrogen or hydrogen. And again, that's going to be a gimme. So you don't get it right, it's okay. If you get it right, okay, go. Extra credit point. I'm trying to remember. I think there's one question. But definitely don't say an ionic bond because then I'm gonna smack you because you know what an ionic bond is, right? You know that that's always a metal and a non-metal interaction. I'm not gonna smack you, but I'll give you a dirty look. Okay, let's see if we can match it. Match the names. Okay, the first I almost said it again. A. A is 82. Which one is 82? Uh, Magnesium sulfate. A. Okay. Okay. Which one is 83? B. Okay. Which one is 84? It's C, as in because it's sulfide, right? That means it's just the sulfur by itself, right? What about 85? D. That's right. And 86? D. Well, that was too easy. It's like all in order. Okay, now we're going to determine which one's polar and which one's non-polar. Okay, so we have carbon tetrachloride. You guys think that's polar or non-polar? That's non-polar. Okay, because the chlorides are all the same on the outside. Carbon's being pulled evenly, right? Water. Hey, it's polar, right? So anytime you see water, we always know water is our polar molecule. That's what makes it so special. Carbon dioxide. It's B because it's non-polar because the oxygens are going to be both pulling evenly. So then there's not going to be nobody's going to have more pull than the other. What about hydrogen sulfide? That would be A. It would be technically considered to be polar. Um, if we actually looked at the electronegativity, not so much, but so it's about evenly pulled. Um, fluoride, hydrogen fluoride. A. Yeah, anytime that you have fluoride, fluoride is always the bully, so it's always gonna, unless they're all surrounded by carbon, if you have fluoride. Okay, what about carbon monoxide? So think about carbon and oxygen bonded together. So is that gonna, who's gonna have a stronger pull? So fluorine is the king, oxygen is the queen. Oxygen always has a stronger pull. So in that case, that would be polar. That's right, because oxygen is going to pull. So then that's going to be A. We're doing really good. Ooh, chemical reactions. Okay. Okay. Which of the following gives uh, the balanced equation for this reaction? You guys agree? Okay. So let's see. We have six potassiums over here. Six potassiums. We have two phosphates, three calciums, and six nitrates, six nitrates. Okay, looks good. So D is the correct answer. D is in donkey. Okay. So what about 94? What type of reaction is this? That is correct. It is D, decomposition. Right. So if we have one thing being broken down to multiple things, then we know that's decomposition. Good job. Okay, redox. So which of the following is a reduction, oxidation reduction reaction? Do you guys agree? Anybody disagree? So are you sure? See. Uh-huh. Okay. So you're saying it's being oxidized because you're adding the oxygen to it, right? Yep. Mm, okay. So that's another way of looking at it. That is definitely true. Let's see. Plus, yep. No, that's correct. You're correct. So, so that would be correct answer. So, let me explain oxidation and reduction. Okay. So, one way of looking at oxidation and reduction, one of them is the loss of electrons, right? So, if you're going from a metal to a charge, an ion, so that would be an example of an oxidation reduction reaction. Or if you're adding on an oxygen, so then you're oxidizing, right? So, for instance, if you burn up sugar or you burn up hydrocarbons, that's oxidizing. That's an oxidation reaction. Right? So it's oxidation reduction reaction. If you add hydrogen, it reduces. If you add oxygen, it's oxidized. Okay. So that's one quick way of looking. Okay. So here would be an example, right? Is this an oxidation reaction? So you're going from a metal to an ionic compound. So that would be the first sign that it's an oxidation reaction. Now, the question is, if the metal starts off at 0 and then it becomes a +1, are we losing electrons or are we gaining? I said, if the metal the metal starts off at 0 because it's 0 charged initially, right? And we go from a 0 charge to a +3 charge, right? Is that losing electrons or is that gaining electrons? It's losing electrons, right? So we know that it lost 3 electrons. So then in that case, loss of electrons means oxidation, right? So then that means that the aluminum is being oxidized, and then the bromine is being reduced because gain of electrons reduction. Okay. So in that case, aluminum is oxidized, bromine is reduced. That would be the correct answer. A. Okay. So I remember Leo. That helps me. Loss of electrons, Leo. And then gain of electrons, Gur, right? Gur. And similar, what this is similar to is happening here, but it's you have to understand oxidation numbers, and we didn't talk about that. So if you just remember, if you get oxygen added onto you, you're being oxidized. And if you get hydrogen added onto you, you're being reduced. Okay. 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 Here. Which of the following describes the oxidation reaction? Loss of electrons or loss of oxygen. B. Loss of electrons, gain of oxygen. C. Loss of electrons, gain of hydrogen. D. Gain of electrons or gain of oxygen. Gain of electrons, loss of oxygen. B. That's right. B as in boy. That's correct. Yep. B. Because remember, loss of electrons, that means oxidation, right? And then also if you're adding an oxygen to it, Okay. How many molecules of water are present in 75.0 grams of H2O? So we have mass. So what can we use to change mass into moles and then change that to number? Okay, where are we going to start at? So 75 grams of H2O. Okay. And then we're going to do what with that? That's our, okay. So we're going to go ahead and divide this by the molar mass, which is 18 grams. And we get that from our 18 grams is going to equal 1 mole. We get that from our periodic table because we know that water is hydrogen. Each hydrogen is approximately 1. And so 1 times 2 is 2 plus 16, right? And then that's H2O. And we want molecules, right? So, but that's moles, right? So now we got moles. So what else do we need? Avogadro's number, yeah. Avogadro's number. Let's see. So for every 1 mole, that's going to equal how many molecules? 6.022 times 10 to the 23rd. And that's molecules. Ran out of room. That's molecules. Okay, not moles. So okay, what do you guys get? Okay. Okay, so if we do that math, we should end up with D as in donkey. What was that? Each hydrogen, yeah. Okay. Avogadro's number is the number of A, particles in 1 mole of substance, B, AMU in 1 mole of substance, C, grams in 1 mole of substance, D, moles in 6.02 times 10 to the 23rd grams element, E, moles in 6.02 times 10 to the 23rd of an element. A is correct. That question, you're trying to be sneaky there. So, 100. And maybe we get it to move up. There we go. Okay. Are you out of here? Okay, bathroom break. Yes. So 1 mole of helium gas weighs A, 1.0 grams, 2.0 grams, 3.0 grams, 4.0 grams, 8.0 grams.
1.0 grams.
4.0 grams. It would
One.
be D as in donkey, right? Because we know that if we look on a periodic table, what is the mass of helium?
Okay.
Yeah. So, and we know that that represents 1 mole. So, yeah, if we said hydrogen, the hydrogen atom, then it would be. But if we said hydrogen, hydrogen element, then it would be two, right? Because it's H2, because it's diatomic. Okay, let's see. The molar mass of magnesium phosphate, a substance formerly used in medicine as an antacid. So it's not formerly used. Uh, so how do we calculate the molar mass? Are you heading out? Okay. Well, we'll be on 6. So if you chance that, and if not, what was that? Yeah. If not, we'll also do it tomorrow, and then what I'll do, I'll work backwards tomorrow. So yeah, yeah, yeah. Okay. Anybody? So what do I need to do? Tell me the secret sauce. How many magnesiums do we have here?
3.
3. And we know that magnesium weighs how much?
24.305.
Okay. So it's 3 times 24.305. Okay. And then how many phosphates do we have?
2.
We have 2. That's right. And then so 2 times phosphate weighs
30.974.
30.974. And then how many oxygens do we have? How many oxygens? Oh, is there 4? No, it's not 4 either. No,
8.
8. Yes, it's 8 because remember it's distributive, right? So that basically means that we have 8 times 4, right? And then we're just going to round up to 16. Now, here's the bad thing, right? Because that should be grams per mole, right? So this is a typo technically. So if we do that math, what do you guys end up with? 262? So it's D, I mean E as in Edward. Okay. 102. 102. We've gone pretty fast. This is very impressive. Okay, so given the following equation, what is the correct conversion factor needed to convert the number of moles of oxygen to the number of moles of iron 3 oxide? So you said 2 moles of iron oxide to 3 moles of oxygen. That is correct. So we're converting number of moles of oxygen to moles of iron oxide. That is correct. Right? So we know that we can get rid of the ones that don't include oxygen and iron oxide. So we can get rid of all of these, right? So then it was is either Z, it's either C or E, right? But they're saying if we're starting off with the oxygen, so that means that we're going to try to get rid of oxygen to get to this, right? So what you want to get to is going to be your second one. So, good job. And then also they gave us the wrong number here anyway, right? So that's 3 to 3. So that's a definitely a not. So 2 ways of getting it wrong, right? Good job. Okay. Let's see. Let's see. See for questions 103 and 105 through 105, considering the following equation. 2 mg plus O2 yields 2 mgO. The number of moles of oxygen needed to react with 4.0 moles of magnesium is A, 1, B, 2, C, 3, D, 4, uh, E, 6. It would be 2 moles. That's right. I'll see you. Yep. And you can come online. We can working backwards tomorrow. So if you need, yeah, if you want to take a look. Um, okay, let's see. So we know that, right? The easiest way of doing it is just putting it in 4.0 moles of Mg over 2 moles of Mg to 1 mole of oxygen. Okay. And so that's how you ended up with your 2. Good job. Okay, the number of moles of magnesium oxide produced when we have 0.20 moles of O2 react completely. So our choices are A, 0.10, B, 0.20, 0.40, or 0.60, or 0.8. What do you guys think?
C.
The correct answer is C, because we know that we're starting off with the 0.20 of oxygens, of oxygen. And we know that the ratio is for every 1 mole of oxygen. Bottom, we have 2 moles. 2 moles of magnesium oxide. Good job. Okay. So, how many moles of magnesium are needed to react with 0.50 moles of oxygen? So, if we have 0.50 moles, 1.0 mole, 2.0 mole, 3.0 mole, 4.0 mole. What do you guys think? Okay, 1.0 mole of magnesium. That is correct. Because we know that in this case, we're starting off the 0.5 moles of oxygen. And we know that the ratio is for every 1 mole of oxygen on the bottom, we have 2 moles of magnesium on top. Oops. Mg on top. So third grade handwriting. So that cancels out. So we end up with just 1. Good job. You guys got this. Okay. Let's see. When 4 moles of aluminum are allowed to react with excess chlorine gas, how many moles of aluminum chloride are produced? So what is probably the first thing that we should do in this case? Any ideas? So if you guys go in the kitchen, right, probably should start off with, what was that? Okay, but what is probably the first thing that we should do though? We should probably write a what? So I'm going to write 4 moles of aluminum, but I should probably do something else first. No, let's think about what's here. What do we have here that's missing up here? A balanced chemical equation. That's right. So we know that we're working with aluminum, Al, plus chloride, right? Chloride gas. So it's Cl2. And we know that that's going to make, what is that going to make? We know it's aluminum chloride. So what is the chemical formula for aluminum chloride? AlCl3. That's right. AlCl3. Because we know that Cl is going to have a -1 charge, and then aluminum is going to have a +3 charge, right? So, okay, so we know that that's going to be our chemical compound. Is it balanced? No, what do I need to do to balance it? Okay, okay, okay. Okay, so now if we have 4 aluminum, then we know that the ratio is a 2-to-2 ratio, isn't it? 2-to-2 for aluminum chloride. So for every 4 moles of aluminum, we'd expect to get 4 moles of aluminum chloride, right? Okay, so the correct answer is D. So let's see if I can write that out so that it looks like it makes sense. So 4 moles of Al. So for every 1 mole, for every 2 moles of Al, we get 2 moles of aluminum chloride. Mm-hmm. So why is it 2 moles? That's based upon the coefficient, right? So that's the reason why we have to get a balanced chemical equation. It's kind of like, when you do a recipe, right? That's right. Then it'll be 3 moles. Yep. So this is always, it's the ratio of this guy to this guy. It's always based upon your chemical equation. Okay? So that's the thing that you always remember. You start off with what you start off with, but you have to use a chemical equation, a balanced chemical equation to determine the ratio. Yeah. Okay. Okay. So how many grams of nitrogen monoxide are required to produce 45 grams of nitrogen in the following reaction? Okay. So we want to know how many grams of nitrogen monoxide are required to produce 45 grams of nitrogen. So in this case, we're given the mass, right? But we know that our chemical equation is based upon moles. So that probably means that we need to change this to moles. So if we have 145 grams, how can I change that to moles of nitrogen? Okay. Okay, so the molar mass of nitrogen, so we know nitrogen weighs about what, 14. Okay, 14, and there's 2 of them. So it's total 28. Okay, so it's 28 grams per 1 mole. And we get that from the mass of nitrogen, each of the nitrogens. So that's N2 for 1 mole. Okay, so then that gives me my moles of nitrogen gas, right? So we can kind of, but we want moles of nitrogen, or actually we want grams of nitrogen monoxide. So we have to look at the ratio. What is the ratio between nitrogen monoxide and nitrogen gas. Okay, so we're going to go 6 moles of nitrogen monoxide. And again, we get that from our chemical equation for every 5 moles of nitrogen gas. Okay, and then if we want the mass of our nitrogen monoxide, what do I need to do? Okay, because we know that nitrogen monoxide is 14 plus 16, right? 14 plus 16, so that's how you get a 30 grams of NO for every 1 mole of NO. Okay, so let's redo our math. Let's see, what is that? What was that 8? You said A? Oh, A as an atom. Yeah. Okay. Okay. So this is another thing that we did not talk about was the activation energy, but we'll talk about it real quick. And again, anything that you guys get right is extra if we don't go over it. So it says the blank is the minimal energy needed for a reaction to begin. So in this case, we would call that the activation energy. Right? So it's the energy to basically get us started for the reaction. And then if you guys take a look down here, this is basically, this represents your activation, the energy, that amount of energy to get us started. Okay. So that would we consider our activation energy. Okay. So the correct answer would be B as in boy. Okay. So a reaction that releases energy, what is that called? Is that going to be an endothermic reaction, an exothermic reaction, a redox reaction, a catalyzed reaction, or decomposition reaction? Exo, that's right. So release, exo. So it's exiting, right? Endo means that you're putting the energy. So the correct answer is B. And then I told you up here, this is B. Okay, so B represents, since I already talked about it, what does B represent? So that would be our activation energy. Okay, so A represents, so that would be the energy of the reactants. That's right. And D represents energy of the products. And then C is going to be what? That's right. C is going to be the heat of reaction. Okay, so we're trying to determine which one is an endothermic reaction, um, and then which one is an exothermic reaction. Okay. So if our change in energy is a negative value, then it's going to be exothermic. If our change in energy is a positive value, it's going to be endothermic. Okay. So the way that you can determine that, if your energy is starting at high value and going to a low value, that would be exo. That's right. And then if our energy starts at a low value going up to a higher value, then that's an endo reaction. Okay. So does that help? Okay. Gases. We're not going to talk about it right now. I will give you an example of a problem, but that's it later on. Okay, now let's talk about solutions. Okay, so which of the following molecules can form a hydrogen bond? We kind of talked about this a few minutes ago, if you guys remember. No yawning. What's that? What is the secret for hydrogen bonds? They have to have what three elements can form hydrogen bonds? That's right. N, O, and F. So which one of these have N, O, and F? C. So the correct answer would be C. That's right. So we'll say N, O, and F. So hydrogen with an N, O, or an F will form hydrogen bonds. Okay. A solution that is prepared by dissolving 2 grams of potassium chloride in 100 grams of water is that is correct, B, the solvent. So how do I know that? What was that? It's a liquid. Okay, so that's true. It's a liquid, and then it's the one that's most abundant, right? So the one that's most abundant is always going to be our solvent. Oil does not dissolve in water because it's non-polar. That's right. Yeah, because water is polar and oil is non-polar, so they don't tango. Okay, potassium chloride dissolves in water. A, the chloride ion is attracted to the dissolved potassium ion. B, chloride ion is attracted to the partially negative oxygen atom in water molecule. C, the potassium ion is attracted to the chloride ion on the potassium chloride, potassium chloride crystal. D, the potassium ion is attracted to the partially negative uh, oxygen atom in the water ion. E, the potassium ion is attracted to the partially positive um, hydrogen atom of the water ion. The correct answer is D. So we want the opposites, right? So positive and you're negative. So the correct answer is D as in donkey. Okay. Which of the following compound is not soluble in water? Which of the following compound is not soluble in water? Lead sulfide is correct. Let me give you guys a hint. Uh, so I can't remember. I don't think you have one quite like this, but you may have something like this, and it deals with solubility. If it's a group 1 metal, it's always going to be soluble. Most group 2 metals are going to be soluble. Okay. Transition metals are the ones that we have trouble with sometimes. Okay. So anytime you see group 1 metals, soluble, soluble, soluble. And then magnesium is almost always okay, or dissolvable in water is another way of saying it. Okay, a hydrogen bond is uh, you're not going to get anything like this, but you guys should be able to figure this out, right? An attraction between hydrogen atom attached to nitrogen, oxygen, or fluorine, and nitrogen, oxygen, and fluorine on another molecule. So the correct answer is A. Okay, the next one. So, what is the concentration in mass percentage of a solution prepared for 50.0 grams of sodium chloride and 50.0 grams of water? Mass percent. Do you guys remember that? That's right. Okay. 200 grams of solution, right? Okay. And then that over 50, right? So then that is what, 1/4 or 25%? Oh, yeah, right away. Then we multiply it times 100. Okay. Good job. Okay. Number 123. 123. Rubbing alcohol is 70% isopropanol by volume. How many milliliters of isopropyl alcohol are in a pint, which is 473 mils container? If it's 70% by volume. So we want to know how much pure isopropanol we have.
E.
You said E as in Edward? That is correct. Right? So we just multiply that 70% times our pint, which is 473, which is going to be give us 331 or 330 in terms of figs. Good job. Okay, so the concentration in mass per volume percent of a solution prepared from 50 grams of sodium chloride and 2.5 liters of water is going to be, okay, the hint is it's mass volume percent. But the thing is that it's typically grams per milliliters instead of grams per liters. So that's going to be important. So then we're going to use our Okay, so then multiply that times 100. And what do you guys end up with? Should be 2.0%. Thirty minutes left. How you guys doing?
Okay,
You're doing okay? You guys can handle another few more questions?
sure.
Let's see. Okay, so I'll ask you guys a question. So I've talked about intermolecular forces, right? Or IMFs. So IMFs makes reference to molecules interacting with molecules. So which which state has the weakest IMFs? Gas, liquid, or solid, or plasma? The weakest. Now, if it's strong, that basically means it's going to stick together, right? If it's weak, that means it's going to do what? Be apart. Which one is the most apart? Solid, liquid, or gas? A gas. Yep. Mm, let's move forward. We don't have too many solution questions. I'm going to move forward beyond this. And most of them you guys can do so far. Uh, except this. You do have some molarity questions. Clear. How many moles of calcium chloride are in 25, 250 milliliters of a 3 molar calcium chloride solution? So that M represents moles over liters. Okay. So this is in milliliters, so we have to change that to liters. So we have 250. We divide that by 1,000. So then go ahead and divide that by 1,000 milliliters. and that's going to equal 1 liter. So then that's going to be 0.25 molar. I mean, liters. And then we multiply that by that value. And then that's how we would get our number of moles. So then if we go that times 3.0 molarity, which is moles per liter. So then our liters cancels out. And so a quarter of that would be, is that 1.33? Don't quote me. All right. 0.25 times 3, 0.75. Okay. Questions? Concerns? Cash? Okay. Okay, during the process of diluting a solution to a lower concentration, A, the amount of solute doesn't change. B, the amount of solvent doesn't change. C, the amount of solute in the concentrated, say, there is more solute in the concentrated solution. D, the volume of the solution doesn't change. E, the water remains, the water is removed from the concentrated solution. A is correct. It's the number of solute. Solute is going to be the same in both cases. Okay. Chapter 9, reaction rates and equilibrium. We haven't talked about this, but it's it's not too complicated. So I'm going to go over what I can real quick. I should say it's not complicated. It's if you know the chemical equation, you'll be okay. And in most cases, they're not going to have you do any major calculations. They're just going to have you answer a couple of questions. So in a chemical, so in any chemical reaction, the rate of the reaction can increase by, and then we're going to talk about this. Let me help you guys out with that. So if we think about a chemical reaction, right, and we think about how fast a chemical reaction is going to happen. So what are some of the things that you think would cause a chemical reaction to happen faster? Heat. That's right. So if we increase the heat, we're going to increase how fast things are going to happen. What else could it also impact a chemical reaction? Let's say, um, let's say, let's decide that. Was that? Oh, cool. Okay. So if we had, let's say, bigger pain, let's say, right? So, and is this something right? Exactly. So if we decrease pain, so you guys have, I mean, take one time, and I have a really and right? So if you guys think about that, so in this case, we know that decreasing the temperature is going to right? But if we increase, if we change the size of the container, well, we know that that's not. So we have more surface area that can speed up our reaction. What about if we have more stuff? Yeah, so that could actually well, because the more stuff you have here, the more reactions you're going to need. So those are all factors. And so in this case, to increase it, if you increase the concentration of your reactant, that's your reaction. So the correct answer would be E as in Edward for this one. And then also technically the size change would as well too. So okay, a catalyst. Um, speeds up the reaction, but it doesn't affect it. So the correct answer for that would be C. So anytime you see something as being a catalyst, and we did one experiment, we had a catalyst. All it does is speed. Okay, so the activation energy of a chemical reaction. So the activation of a chemical reaction is the energy that is, because A must be removed from the mixture, B must be released from the mixture, C initiates the reaction, D activates the catalyst, uh, E the difference between the energies of the starting. It's right. So we know the activation is what we have to get started. Remember that big old hump that we have to get over. In a catalyzed chemical reaction, one function of the catalyst is to decrease the concentration of the reaction. Maybe not so much. Did you say A or B or what? You said E. Uh, so increase the energy given off. Nah, it's not going to be E because you're not going to be increasing the energy.
It's not C?
So you change the equilibrium concentration of the products. No, so you're not messing with the concentration of your products or your reactants, right? The concentration is going to be what was that? You said B. No, not B. Did you say A? Yes, the correct answer would be A. It would increase the number of successful collisions. So catalysts, they help orient, right? So that's how you help. So the number of products, right? All it does is it helps get it in the right shape or in the right form to do that. So the correct answer is A. Good thinking, though, right? But then that's what these are going to be extra points, right? These three extra points here. Okay, so let's see. Let's see. Indicate the effect of the change on the reaction rate. A uh, would be increasing. B would be decreasing. A catalyst. What is a catalyst? It's going to increase. It's going to speed everything up. Okay. What about removing some of our reactant? B, right? It's gonna it's gonna decrease. Yes. Yeah. Uh, the temperature, doubling our temperature. Hey, that's gonna increase. Yep. The concentration of the reactant is decreased. It's gonna be. Yeah. 41, more collisions between the molecules. Hey, that's what speed it up. Yeah, the more things collide, the more things are going to react. Okay, I think you guys okay if we stop there, and then what I'll do tomorrow is I'll stop right back, and then I'll work in, and then so if you guys come tomorrow or zoom in, you can zoom in tomorrow, and then we'll work our way backwards, and then I'll go all the way to the very beginning. So.